let's analyze the Twin Pigs Fly Lab before we get started. The entire purpose of this lab is to determine the centripetal acceleration when we have a pig flying around. So, by the end of this, we should be able to find A sub C. Now, what are we going to need? We're going to need a flying pig. I have these already attached to my ceiling. You guys have been playing with them for a while. Now's the time we get to play. Now, you're going to need a stopwatch. You can use your phone as a stopwatch and a meter stick. Make sure your meter stick is turned to centimeters, not inches. Don't use the inch side. Now, this is the theory part of our lab, and let's pay a little bit of attention to what it's saying. When an object travels at a constant speed along a circular path, we say it has uniform circular motion. Know this definition. Uniform circular motion occurs when an object travels at a constant speed in a circular path. Now, if the speed were changing, it wouldn't be uniform, and that's kind of ugly. We're not going to do those. Any object that moves in uniform circular motion is accelerated, all right, toward the center of the circular path. All right, so it's always toward the center, and this is our centripetal acceleration. Now, the formula for centripetal acceleration is v squared over r. All right, make sure you keep that one straight, where r is the radius of the path. The net force is ma. During circular motion, the centripetal force is equal to mv squared over r, and is toward the center. And this is our centripetal force. When an object suspended moves in a circular path, it creates a conical pendulum. That's just a fancy word for saying it's making a cone as it spins around. Okay, that's what the pig will look like as it flies around. The string sweeps out a right circular cone. Okay, all the right circular cone means is that right there. In this experiment, you're going to measure the speed of the object that produces this conical pendulum and show that the force is mv squared over r. So we're basically just going to find centripetal force. Now draw a free body diagram of the pig as he or she flies. So here's my pig. We've got a square pig. I will not traumatize you with drawing my pig. Now, FG always goes straight down. And the other force acting is the tension of the string. Now let's look at this. The tension of the string goes like this. Let's say our pig is moving this way. The tension of the string is back to the center. So we see we're going to have some Ty that's going to equal Fg, and then some Tx. Now we're not going to fully analyze this. Wait till you get to AP to do that. But just notice that in this case, the centripetal force doesn't equal either the force of gravity or the tension. But that's okay. Now, does the pig accelerate in the vertical direction? Guys, if your pig is sweeping out a very nice circle like this, it should be moving in a horizontal plane. Because it's moving in a horizontal plane, basically what that means is you could take a ruler and put it right up under here and it won't hit it. So the answer is no, it doesn't accelerate in the vertical direction. It's not flying up and down, it's flying in this horizontal circle. Now, does it accelerate in the horizontal motion, in the horizontal direction? Of course, yes. So, since Tx has to equal Fc, Tx equals mv squared divided by r for my pig. This is important. Now, the pig's already going to be attached to the ceiling. Don't damage their wings. Let me rephrase this. Do not damage their wings. If you click it when the wings are pushed in, then you'll break them. So make sure that the pig looks something like this. Here's the pig, and the wings are all out like this. He's happy. Don't have his wings pushed in like this, or you'll wind up breaking my pig wings. And then you'll have an angry teacher, which is not good. It looks like a shark, doesn't it? Okay. Now, if this is what the pig looks like when it's just hanging down, lift it about 30 degrees and give it a very gentle shove. Gentle shove. Give it a gentle shove. All right, very slight. Just so it flies in a circle. If you push too hard, it's going to start swobbling all over the place. If you don't push it hard enough, it's going to wind up stopping. When it's time to stop it, grab it carefully. Okay? Don't ever just snatch it or jerk it. You'll break the string, you'll break the wings. Now, once the pig is up and flying, measure the radius. Now, folks, let me give you a hint. If this is the pig, this is the pig, he's flying around in a circle like this, hold your meter stick underneath and measure it carefully. Measure it from here to here. You can hold one end. If you measure it this way, you've got the diameter. To get the radius, divide the diameter by 2. This is probably the easiest way to do it. So suppose you measure the diameter as a whole meter, then the radius, 1 meter divided by 2, is 0.5 meters. Now this is not accurate. You cannot use these numbers for your lab, but I'm going to give you a sample lab using them. So I'm going to say my radius is 0.5 meters. Now, since the pig flies in a circle, the speed is 2 pi r. Divide the time for one cycle, divide the time t for one cycle to make your measurements of t more precise. Measure the time by taking the pig 10 revolutions and then divide by 10. Okay, so let's say the total time is 64 seconds. Just made that up. The period will be 64 divided by 10, or 6.4 seconds. Now, this is clearly not going to be the case because the pig isn't going to take 6 seconds to go around once. It should be more like 2 or 3 seconds. So, my period is 6.4 seconds. My radius is 0.5 meters. So the velocity is 2 pi r divided by t. Well, that's not showing up. 2 pi r divided by t. So my speed is 2 pi 0.5 divided by 6.4 seconds for my example. So 2 times pi times, I lost my calculator here. 2 times pi times 0.5 divided by 6.4. I get 0.49 meters per second. So AC is v squared over r, or 0.49 squared, divided by my radius of 0.5. And what do I get when I do that? I get 0.48 meters per second squared. Is that right? 0.49 squared divided by 0.5. Yep, that's what I get. Okay. My numbers are a little weird. What do you conclude about the direction of the net force that keeps the pig flying? Well, it's got to be to the center. How does the pig overcome air friction? Well, the pig's flying. It's got wings. If you don't believe it, try putting the pig in motion without the wings going. When you're done with the lab, it's time to take your quiz. You can use these notes.